class starts, and this might be just a little bit too ambitious, but I'm going to try to get in the inverted slider crank before I have to run off to class here. And so a similar treatment that we have, where we have the vector loop that we can make x and y equations out of. And the constants now are A, C, and D. B is not a constant because this B can change in length right here. And theta 1 is the ground link. The input is theta 2, right? So we're going to put in a theta 2. The variables are B, theta 3, and theta 4. And you might think, well, that's 3 unknowns, and we have 2 equations. But we have an additional equation, and that is that theta 3 and theta 4 are related to each other. This gamma is often going to be like 90 degrees, right? So these are related to each other, so we have an extra equation, so now we can solve it. So this is the method. We take these 2 equations, and maybe we solve for the y component for B, and then we can substitute into the x component up above, right? And we can also create some variables to assist in solving. We can also use this thing creatively, right? So what we want to do is like we could simplify and make into this equation right here. If we can take this P, this Q, and this R, and we substitute all of those things in there. So we've simplified the equation. We note that everything that's in here, especially if we have a theta 2 that we know, is a constant, right? So now we use the half angle identities again to get these, rearrange these things, to get the tangents put in there. And now you can see that's a quadratic equation. All we have to do is like substitute the r's and the R, Q, and all these up there. So we get an S, T, and U. And now we're able to find, from this, we're able to find what we're able to solve using the quadratic equation and get a theta 4. And then once we have the theta 4, we're going to be able to find all the other things. And because there's 2 solutions, we also have a crossed, or the potential to have a crossed configuration. So the example I chose was problem 411A, right, which is in chapter 4 here. It's one of the problems where we use the 6, 2, 4 in a 90 degrees. And here's the Excel solution that we would generate. But let's see, and I didn't even actually write out this solution as part of this thing. Boy, that was a lazy approach. But it was probably because I was doing so much work last semester, last year, and just couldn't get around it. So maybe I should grab the Excel right here and put it side by side with this, with the camera right here, and take a look. But class is about to start, so I don't know if this is going to be the smartest way to use our time together. See, I just got the reminder that class is in 10 minutes. But you could see from my Excel here that I've made, here are the inputs, 6, 2, and 4, and 90 degrees is the gamma, and 30 degrees is my input. So I have my P, Q, R, S, T, and U are all right there. And as you'll see from the summary sheet right here, I've taken my P and I found it by this equation right here, and it comes out to the exciting value of 1. And my Q is also a pretty long equation right in there. And then R is pretty simple. R is pretty straightforward. And S is pretty straightforward. It's just R minus Q. And then we have T is just 2 times P in there. And then, so up here, up above, we have our, here's our quadratic equation, and our tangent as part of that. So we have two different angles that this thing could possibly exist in, and once we find that angle, all we need to do is add in the 90 degrees to it to find the theta 3. And then for B, all we need to do is go back up to one of the original equations, right? All we have to do is probably just, I think we could either solve for, it's probably this guy. This is probably the easiest one to do, right? You could solve for B by coming back up through there. It's actually one of the steps that I probably describe in here as part of this is probably, there's probably one in here where we solved for B. Yeah, right here. See, we could just solve for that equation right in here, and that's what we're doing right up here. Yeah, the one that's in the sign of the thing. And you'll notice that B is actually equal to the same thing. And I have another video where I put together how I made this Excel spreadsheet. But you could see how I've plotted the thing out. And you can kind of see what happens here if I have different inputs, like what that thing looks like. So I need to run to class. So we're going to call this a shortened video. We're not going to write down all the numbers. Did you need me to fill out the numbers for you? You could put numbers into equations, and you could believe that this is the answer, right? Sure. See you in a couple of minutes.